Hi, I'm starting a new series about Hungarian computers, especially the 8-bit computers, and this video is the first episode where I will talk about history. Before jumping into the technical details, I feel it is necessary to talk about the historical and economical background. I'm jumping back quite far and starting between the two big wars. That time Hungary was a kingdom without king, and we had a governor who acted like a president. The society as well as the education was very polarized. A lot of people had basic education, but at the same time we had very good high schools and universities. Hungary gave a lot of scientists, engineers and other very smart people to the world, especially if we compare the number of them to the size of the country. But unfortunately most of them left Hungary and never returned back. The reason behind is very dark. We followed the German way. From mid-1930s, the persecution of Jews had been started. A lot of smart guys left Hungary. To be honest, when I started to collect a list of those people, and this is just the tip of the iceberg, I really realized that we lost a lot of talents. Let me name a few of them. Eugen Wigner, Leo Szilard, Denis Gábor, Theodor from Kármán, John G. Kemény, John von Neumann. There were many more, and most of them find their place in the United States. What is interesting, they had critical role in the development of nuclear bombs. For example, Szilard Leo approached Einstein, and this is how the project started. And also I can name Edward Teller, he was the father of the hydrogen bomb. As you can see, they were very smart scientists, but they never returned back to Hungary. But I'm running forward. I have to talk about the ones who stayed. It is a tragedy because hundreds of thousands of people were transported to camps, or they were just simply killed and shooted into the Danube. After the Second World War, you may expect that it became a bit better, but unfortunately the communists started to take over, and when they did, they started a new persecution. They replaced the Jews with bourgeois. Of course, a well-educated engineer, doctor or scientist was affected because they became bourgeois. So what happened? They started to leave the country. For example, there was Albert Szent-Györgyi. He got the Nobel Prize in 1937 and left Hungary in 1947. So it started a second wave of exodus. But let's talk about the ones relevant to information technology. John von Neumann. Primarily he was a mathematician and he also worked on physics and game theory, so economics as well, but he also worked on computer science. He described the computer architecture still used today, but in fact it was based on Macaulay and Acker's work. The von Neumann model describes a design architecture for an electronic digital computer. Such computer must have the following components: a processing unit with both arithmetical unit and processor registers, a control unit that includes instruction registers and program counters, memory, which is internal and stores data and instruction together, external mass storage, and some kind of input and output devices. He also emphasized that instructions are executed next to each other, so in a serial manner, and because it is possible to change the code because it is stored in the memory, such computer can be utilized universally. At that time, the Communist Party started to take over the power in Hungary, as I already said, but they also realized that we cannot lose all the smart people. As a response, they closed the border and built the Iron Curtain. But it was not hermetical, and smart people find a way to leave the country. For example, there was Andy Grove and Leslie L. Wadas. Both of them were employees of Intel. They joined Intel just few days after the foundation, so Andy Grove was the third one, and Leslie L. Wadas was the fourth one. Later on, Andy Grove became the CEO of Intel, while Wadas was responsible for chip-making operations. Charles Schumann worked for Microsoft, and he led the development of Office products. He made a lot of things, but what is interesting for me is that he was the second Hungarian astronaut. He used his wealth to travel the space. I already mentioned John G. Kemény. He was a mathematician and computer scientist, and with Thomas Kurz, they developed the basic programming language. If you think the situation was not bad enough, so we lost a lot of people, and we also closed the borders, the Western Bloc established a countermeasure against the communists. So they introduced the COCOM list. It was about new technology, so it was forbidden to ship from the Western countries to the Eastern Bloc, for example, computers and any equipment required to develop or manufacture those stuff. Furthermore, the leadership of the bloc was a bit strange. They were against cybernetics or computer technology or anything like that because they said it is not a real science but something coming just from the West. I don't know why, maybe they were just paranoid or not smart enough because it was required to develop new and better products, and especially it was a must for the army, so really strange things happened that time. They took the scientists to camps, so they imprisoned them, and they had to work there. So in one hand it was a must, in the other hand they were just imprisoned. I cannot describe it better than it was just crazy. But no one lives forever. Tavaris Stalin died in 1953, and everything started to change. The Hungarian Academy built the first computer. It was based on Soviet Ural 3. Unfortunately, I do not have a picture about this one, but we have a very nice museum in Szeged. If you spend a few days there, it's worth a visit. At the same time, computer science also found its way to the education. For example, there was Kovács Mihály. He was a high school teacher and started a hobby professional school in 1958, and later on with a student they developed the Micromat. It was a kit to teach digital technology, logical circuits, so the basics of computer technology. At the same time, many companies started to work with the digital technology. For example, there was the EMG. They built their first transistor-based calculator, which became later on a series. I know it is not a computer, but it is quite similar, and in the US, Commodore or Texas Instruments started the same way. But if you think it was a race similar to the Western countries, you are wrong. In 1968, the Central Physical Research Institute introduced the TPA 1001. It was based on DEC PDP-8, so it was a computer, but the name, the TPA, meant something else. That time the economy was dictated from above, so we had 5 years plans, and this institute was not allowed to produce a computer. So they named it a stored program analyzer, which sounds like a measuring equipment, and this is what they were allowed to produce. Another good example for the centralized economical system is the Common Economic Assistance. I'm not pretty sure if you know what that was. So it was a system where the Eastern Bloc countries discussed who produced what. So for example, they divided, this country will produce cars, this country will produce electronics, this country will produce ships, etc. Maybe it sounds efficient, but in fact there was no competition between countries and companies, so it reduced the willingness to develop something new or keep it up to date. So in 1968, they decided to have a unified computer system. Of course, it was initiated by Soviet Union. It was Kosygin who sent out letters to the leaders of the countries, and they started the discussion. They split the development effort. So, for example, Bulgaria started to produce storage systems. Here in Hungary, we produced printers and terminals. So as you can see, it reduced the development cost. But as I said, there was no competition. The first machines were produced in the early 70s, and it had a major flaw. They also decided to copy the IBM 360 architecture and keep it compatible. The flaw was that if you copy something, for sure you will be behind your competitor. Because they are developing something, then they release it, then you start to copy while they are developing the new technology. Hungary also got approval to produce smaller computers. Videoton started to work on the R10 family, but it was not developed here in Hungary. In fact, it was based on a French machine, so it was again just a copy. What is interesting, officially there shouldn't be any kind of competition, but in fact there was some competition. But it was a little bit strange. I already mentioned two competitors, so there was the one which produced already the calculators, and the other was the Physical Research Institute, and they tried to push their own computers. But the competition was not decided in the market, but in the ministry, and they brought many times political decisions, especially if they made the decision on one of the central committee meetings of the Communist Party. There are many examples, but there is one story which stands out. In Hungary we produced floppy disks and drives, and one talented engineer had a good idea. His idea was to make the system more durable, so he reduced the size and designed a harder shell for the floppy disk. The whole system was patented in 1974. Several Western companies tried to get a license of this system. So for example, there was Commodore, Sugart or Sony, but they failed. At one point Jack Tramiel traveled to Hungary to have a discussion, but he was not able to meet the leaders of the company. No one knows what happened exactly, but as I heard there was a kind of party meeting or something like that, which was more important for those leaders than meeting someone who wanna make a deal. So those companies failed to license the patent because of the Hungarian bureaucracy, but when the patent ran out, they started to produce their own variant. The most common is the 3.5-inch version, designed by Sony, but there were other alternatives. For example, on the picture you may see next to the MCD-1 a 3-inch variant, which was used by Amstrad. At this point we are reaching mid-70s, and I would like to mention two more important things. The first is a political decision. Hungary was the happiest barrack in the Eastern Bloc, and it was called that way because they put a lot of money on welfare spendings. The result was a better average standard of living compared to other Eastern countries. But the second I would like to mention was against that. In the 1970s there were two oil crises, and to keep up this politically decided welfare system, they had to spend more and more money on it. They started to reduce spendings on the army and on other areas which was not affecting directly the people. And unfortunately, computer technology was one of those areas. Right now I'm closing this history lesson. I hope it was not too boring for you, and you will join me for the next one. There I will talk about the 8-bit computers in Hungary, especially focusing on prototypes, hobbies, as well as I will talk about the school computer program. Wish you all the best. Goodbye.